Hello, my name is Luke Sullivan, and welcome to my arc length project. So the path that I chose to trace out was a small little walking path around my church, and you can see it right there. It's pretty nice. This is the portion of the path that I'll be finding the length of, this little arc right here. And then, as you can see, I oriented it so I placed the origin right here, and then I traced out some points using the distance function on Google Maps to find coordinates approximately on this arc right here in order to transfer it over to a graphing software. So I did this. I found these coordinates extracted from Google Maps, and I placed them into the graphing software, and it gave me this graph with this very nice, super long equation, and essentially it is a quintic, and it has an r-squared value of 0.9992. This means that it is the graph is very representative of these coordinates that I have inserted, so we should be looking for a quite valid graph. Then I began to calculate the arc length. I did this using the arc length formula, seen right here, and after crashing several graphing calculator websites, I was able to borrow a graphing calculator and plugged in right here, as you can see. If we go back to the previous slide, the last x-coordinate that I had was 570, so I took it from 0 to 570. So that was our integrands. And then I did it using the arc length formula, which is the integral of the square root of 1 plus the derivative of whatever the equation is squared. And then right here you can see 1 plus derivative. Y1 is the very long quintic formula that we found for the comparison of the graph, and we're solving it x equals x. We square it to get 793.827. So that is the length of this path right there. And then if we move along, we can check the validity of this using a function of Google Maps. So I went in to Google Maps and I checked the length of my path right here and found it to be 806 feet, which is very close to the 793 feet that we found using the arc length formula.